Sometimes in life we come across problems that can be represented and solved with equations. In this video we'll focus on linear equations or equations with two unknowns, like those displayed here. To solve the problems, we follow a set of steps. First step is decide on the two unknowns, for example x and y. Don't forget the units. We write down the two equations connecting x and y, and we solve the equations simultaneously. Now we've learned a number of methods for doing that over the last few videos. Then we check our solutions in the original data or in the original equations, and you write down your answer in sentence form. Some text might describe the process a little bit differently, but ultimately it's the same. I've also heard of it, the process described as defining the variables for each unknown, write down two equations from the information provided, solve the equations simultaneously, and interpret the solution and write it in sentence form. So let's look at an example. 2 adult tickets and 3 children's tickets to a baseball match cost $45. 3 adult tickets and 4 children's tickets cost $64. We want to find the cost of each ticket. So step 1, we want to decide on the two unknowns, for example, x and y. This time we will let x be the cost of an adult ticket and y be the cost of a child's ticket. Now we write down our two equations, step 2. So we know that 2 adult tickets and 3 children's tickets cost $45. So we have 2x plus 3y equals 45. And we know that 3 adult tickets and 4 children's tickets cost $64. That becomes our second equation, 3x plus 4y equals 64. Step 3, we solve simultaneously. In this example, because we've got both equations in the general or standard form, the same thing, two different names for it, we're going to solve them by elimination. So we're going to times the first equation by 3 and the second equation by -2. In this example, we're multiplying the second equation by -2, which is going to give us the leading coefficient of x is going to be the same number but a negative, which tells me that we're going to add the equations in the next step. So this gets us 6x plus 9y equals 135, and negative 6x, negative 8y equals negative 128. So we're going to continue step 3. Now the leading coefficients become the opposite side, so we add the second equation to the first equation, and we can solve and we find y equals 7. Now we substitute 7 back into one of the original equations to solve for x, and you can see that here we get 2x plus 3 times 7 equals 45, and then we negative 21 both sides, divide by 2, gives us x equals 12. Now step 4, we check our solution with the original data, so we substitute our numbers back into one of the original equation. We find that it works, so it's worked. Now we write it in a sentence form. So an adult ticket costs $12 and a child's ticket costs $7 in this example. Let's look at another example. John buys 3 daffodils and 5 petunias from the nursery and pays $25. Julia buys 4 daffodils and 3 petunias for $26. Determine the cost of each flower. Step 1, we decide on the two unknowns. This time we're going to let D be the number of daffodils and P be the number of petunias. Now we write down the equations connecting D and P. So we had 3 daffodils plus 5 petunias equals $25. 3D plus 5P equals 25. And 4 daffodils plus 3 petunias equals $26. Therefore our equation is 4D plus 3P equals 26. Now we can solve this equation simultaneously. Again, both of these equations are in the general or standard form, and therefore they're best solved by elimination. This time we're going to times the first equation by 4 and the second equation by 3 to give us the same leading coefficient on the D. And we do that. And because 1 is not a different sign this time, we've got to subtract the second equation from the first equation. And then we get 11p equals 22. Don't forget we're subtracting 12d, subtract 12d equals no d. 20p, subtract 9p equals 11p. 100 subtract 78 equals 22. We're subtracting the top row with the bottom row. And we solve to find out that P equals 2. Now we continue step 3. We substitute P back into equation 1 to solve for D. As you'll see here, we get 3D plus 5 times 2 equals 25. Negative 10 both sides. Divide by 3, which gives us D equals to 5. And therefore, we can check our answer. So we substitute those P equals 2 and D equals 5 back into one of our original equations, and we find it checks out. And then we write our answer in sentence form. So daffodils cost $5 and petunias cost $2. Now let's look at a more challenging example. Those ones have been a little bit more obvious. The equations in this example are not immediately obvious. So we've got a car that left Melbourne for Adelaide at 11 AM and travelled at a speed of 70 kilometres an hour. We've got car B, left Melbourne for Adelaide at 1 PM and travelled at an average speed of 90 kilometres an hour. What time will the car B catch car A? Now, this is a little bit harder than some of the examples we've been doing. So we're going to first of all decide on the two unknowns. In this example, we're going to use X as the number of hours travelled by car A and Y be the number of hours travelled by car B. Now, this is the hard part, deciding on the equations. So we know car A, the total kilometres travelled is going to be however many kilometres per hour you travel times the number of hours. So we've let X be the number of hours. So the first equation is the car A total kilometres equals 70 times X, which is our number of hours. Similarly, car B total kilometres travelled 90 kilometres an hour times the number of hours, Y. Now we know that when they've both travelled, they're going to both travel the same number of kilometres. They're travelling a different amount of time. But we know because they're travelling the same amount of kilometres, we can make these two equations equal each other. So we've got 70x equals 90y. But we can't leave it like that, so we have to rearrange it. So we divide both sides by 90, and we get y equals 70x on 90. Now that's our first equation. Now you also might be able to tell from the information provided that car A is going to travel for 2 hours longer than car B, because by the time they meet, it left 2 hours earlier. So we can write another equation. X take y equals 2, which means the hours that X travelled, car A, take y, the hours car Y travelled is going to equal to 2. And we know that because we know car A is going to travel for 2 hours longer. Do you guys notice anything about the equations here? Pause, have a look at them. Our first equation is in the gradient intercept form. Whilst it might not look like we're used to, that's the same as writing 70 over 90 or 7 on 9x with no y-intercept. The second equation is in the general form. So instead of using the elimination method like we have in the last two examples, this time we're going to solve by substitution. Because one of our equations, we know what y is equal to, and we can substitute that into our other equation and solve for x. So we substitute 70x on 90 into our second equation, and now we can solve for x. So what we do is we'll times that all the terms in that equation by 90 to get rid of the divided by 90 in the second term, and you get 90x take 70x equals 80. And now we can just collect like terms. We've got 20x equals 180, divide by 20, we've got x equals 9 hours. Now almost there. What we're going to do first though is we're going to substitute that back into our original equation and solve for y. So we get 9 take y, and end up y equals 7 hours. Okay. Now we can check that in our original data. So we've got one of our original equations, and we substitute x equals 9, y equals 7, and we find out, yep, that works. It's great. Now let's go. So I'd like to point out here as well that you've got to read the question. The question said, at what time will car B meet car A? We've found out how many hours they're driving for. We haven't found out at what time. So now we have to plug this information in and add how many hours on to what time it left. So car A left at 11 a.m., drove for 9 hours, finishes at 8 p.m. Car B left at 1 p.m., drove for 7 hours, and finishes at 8 p.m. And that's how I'll answer. Finishes at 8 p.m. Thanks, everyone.